Hello, welcome to PhyzQuest. This video is about the solution for question number 9, JEST 2019, Part A. So the question is, a very long solenoid, the axis is along the z direction of n number of turns per unit length, carries a current which increases linearly with time, and the current is I is equal to kT. So we need to find out what is the magnetic field inside the solenoid at a given time t. And here basically we need to find out the magnitude as well as the direction. Now, this question is based on the topic electricity and magnetism. And the concept here is Amperes Law. Now we know that electricity and magnetism are interrelated. Electricity can produce magnetic field and magnetic field can produce electric current. For example, consider a current carrying loop. A loop having continuously flow of current can produce a magnetic field. Now, a similar manner, magnetic field can produce electric current. So the example could be the electromagnetic induction. Now, here the current is, in this case, the current carrying loop is producing a magnetic field. Now this is a circular shape. So what if we have a different kind of shape? How to relate the shape of the current carrying wire to the magnetic field produced. So there comes the Amperes Law. So according to the Amperes Law, the magnetic field in space around an electric current is proportional to the same electric current. So we can say that the definition is the magnetic field produced by any current carrying path is the sum of the magnetic field due to the length elements along the path, which is equal to the permeability times the current enclosed by the path. Mathematically, we can say the line integral of the magnetic field B around any closed path equals to the mu0 times the current enclosed by the path. Now this is your Amperes Law. So this can be applied for any kind of a general situation of current carrying conductor having a closed path. So our question is based on a long solenoid. So we have a long current carrying solenoid in the direction of z axis like this. So here this is a wire where current is flowing. So direction of current is like along this direction, okay, here towards this, and the direction of this is z axis. This is the axis of the solenoid, that is z axis. So now it is given that the current in the solenoid is I is equal to kT. So with time, that means see, I is equal to kT means it's dependent on time, and with time it is increasing. Now here, according to the Amperes Law, it is given that the magnetic field is dependent on the current, and it is the permeability times the current, and that is for a single turn, that will be mu0 times the current. Suppose there are a large number of turns, so you have to consider the number of turns as well. So the formula to find out the magnetic field for a current carrying solenoid is B is equal to mu0 Ni. Here n is multiplied because there are n number of turns in this solenoid, which is already given in the question. So B is equal to mu 0 Ni. N is your number of turns in the solenoid. Now I value is already given, which is equal to Kt. So ultimately the value of B is equal to mu 0 Nkt. But we are not done yet. We need to find out the direction as well. So here, to find out the direction, this is your solenoid again. Now the magnetic field generated in the center of a current carrying solenoid. See, the question says we have to find out the magnetic field inside the solenoid. So the magnetic field generated in the center of the solenoid of this current carrying solenoid is uniform and is directed alongside the axis of the solenoid. So the axis of the solenoid is along z direction here. Now we can understand, see, axis of the solenoid is z direction means, and the magnetic field inside the solenoid is directed along the axis of the solenoid means magnetic field is along the z direction. Now you can understand this another way. Here we need to apply the right hand thumb rule. So see, here current is along the wire. So current is along this direction. Okay. So when you apply the right hand thumb rule, so the thumb is signifying the direction of the magnetic field like this. So this is your direction of the current like this. This thumb is signifying the direction of the current, and the fingers are signifying the direction of the current, whereas the thumb is signifying the direction of the magnetic field. So here this is pointing towards this direction means it is the z axis. So that means the magnetic field is along the z direction. So we can finally write the magnetic field along with the magnitude and the direction as B is equal to mu 0 Nkt z cap. So this is the answer we have calculated. Now let's check the options. So here if you check the options, you can see that option A is matching with our result. So the correct answer is option A. Thank you.